Hello everybody, welcome back to geometry for second semester. This is the first recording we've had for the second semester, but I know we are already in week 2, but I just wanted to say welcome back. Fresh start with the new semester, so that's always a nice thing to have a fresh start. Meaning that your grades are reset and we are starting from scratch for the second semester. A reminder that you should be taking notes as you watch the recording. It's going to be helpful for you in learning the new content and also having some examples to look back on when you go to do this week's assignments. So just a friendly reminder to make sure you've got your math notebook out. If you don't, you can click pause and grab a math notebook and join us when you've got your math notebook and you're ready to take notes. So I do have some warm-up problems that I want to start with that's going to help you with being successful with Unit 5. And the first one is to simplify a radical. So you will need to simplify radicals throughout Unit 5. So let's make sure that we're good with that and practice. So you are just going to simplify the square root. That square root goes all the way over 50. So simplify the square root of 50. And then last week you, in Unit 5 Session 2, whoops, I meant to say Unit 5, Unit 5 Session 2, looked at finding geometric means. So let's review and make sure that we're good on that. So number 2 is a review from Unit 5 Session 2. Find the geometric mean of 6 and 9. And you also looked last week at how finding missing parts in similar right triangles relate back to finding geometric means. So let's make sure that we're good on that. So go ahead and click pause and try these 2 warm-up problems in your math notebook, and then when you're ready to check your work with mine, go ahead and click play. All right, so when we simplify radicals, what we want to do is we want to look for factors within the number that we're trying to simplify that have factors that are perfect square roots. And remember, perfect square roots are things like 2 times 2 is 4, so 4 is a perfect square root. 3 times 3 is 9, so 9 is a perfect square. 4 times 4 is 16, and I can keep going, but 4, 9, 16, 25, 36, those are all perfect square roots because we can find the square root. It gives us a solid whole number. So we want to look for factors of 50 that have a perfect square in them. And I'm thinking in my head, okay, 50, that's, if we have 2 quarters, we get 50 cents. So 25 times 2 gives us 50. And we know that 25 is a perfect square. So I'm going to rewrite that square root of 50 as I know that the square root of 50 is the same thing as saying the square root of 25 times 2. And then I can rewrite that further and break it apart and say the square root of 25 times the square root of 2. That's the same thing. If we put that together, that would be the square root of 50. And then we can actually take the square root of 25, right? The square root of 25 is 5. Is the square root of 2 a perfect square? No, so we're just going to keep it as the square root of 2. And that is the simplified version of square root of 50. It would be 5 square root 2. All right, so looking on to that second question where we're finding the geometric mean of 6 and 9. So we learned last week that the geometric mean of 2 numbers follows this format. If we have 2 numbers, let's say A and B, that we're trying to find the geometric mean of, well then it follows this pattern that the geometric mean, if it's x, x squared is equal to A times B. And then another way that we were introduced to the geometric mean is through a proportion, that if we have A over X, remember X being the geometric mean, and X over B, that we can set up a proportion and solve for X. And really, this proportion here, remember if you cross multiply to solve for a proportion, we would have A times B equals x squared, because x times x is x squared. So that's how we get that formula of x squared equals a times b, where remember x is going to represent your geometric mean. So let's find the geometric mean of these two numbers. So in this case, let's change colors here since we're actually working. Our geometric mean, x squared, will be equal to 6 times 9. And I know that 6 times 9 is 54. How do we solve for x? If we've got x squared, how do we get x all alone? Well, what's the opposite of squaring something? Taking the square root. So I'm going to take the square root of both sides. And I'm going to go up over here. So that leaves me with x equals the square root of 54. Hey, we get to try simplifying a radical again. So are there any factors in there that are perfect square? Well, looking back originally what we had, 6 times 9, that gives us 54, and I know 9 is a perfect square. So I'm going to rewrite this as square root of 9 times square root of 6. And then I'm going to go ahead, and I know the square root of 9 is 3. Square root of 6, we have to keep a square root of 6. So that means that our geometric mean is 3 root 6. That's in the most simplified format. So we found the geometric mean. And you get to do that a lot when you're working with similar right triangles, as we found in Unit 5, Session 2. So I'm going to move on to the next slide, so if you need more time, go ahead and click pause. Whoops, we already did that. I probably should have done that on that slide to have more room. All right, so what are we going to look at today and this week? So this week, we're going to do Unit 5, Session 3, where we look at some special right triangles, 45, 45, 90-degree triangles, meaning that there's one angle is 45, the other is 45, and then their third angle is 90 degrees. And then another special type of right triangle where we've got one angle is 30, the other is 60, and then the last one is 90 degrees. And each type of these special types of right triangles has some pretty cool patterns that occur between the legs and the hypotenuse. So we'll look at that. And then you're going to take a quiz this week over sessions 1 through 3. And then we're going to take a look at Unit 5, Session 4, which gets into looking at some trig ratios. So we're going to get into some fun trig ratios. I love trig ratios. It's a really fun session. So let's review some of the things that we've learned so far in Unit 5. So make sure you're taking notes. Some quick tips before we get into the Session 5 or the Unit 5 stuff. Make sure you're checking your grades. So just to go over some tips as we start a new semester, make sure you're checking your grades often. So that grades tab not only can tell you how you're doing overall in the class, but it's a good guide to use to see what you've turned in and if you're missing any assignments. So refer to that grades tab often. Also make sure you're seeing how you did on the assignments and actually clicking on the assignments in the grades tab after they've been grading to see specifically what you got right, what you got wrong, and leave that and read the feedback that I leave within the assignments. Last but not least, make sure you're reading through the updates daily. I don't always post to updates, but when I do, it's important info. So just when you log on to Geometry, quickly, you're already going to land on the updates page. So just scroll and see if there's anything new you need to read. And then make sure you're checking your messages in Schoology and your emails daily so that you can see any communication from me. All right, so Unit 5, Session 1. So let's review something that you did in Unit 5, Session 1. And this actually comes from one of your assignment questions. So this is pulled straight from one of your graded assignment questions. So here we've got a railroad problem where it says the safety rules for a playground state that the height, so this is going to be the height of the slide and the distance from the base, so that'd be here, the distance from the base of your slide to the front of the slide must be in the ratio of 3 to 5. And you can see that that's listed right here, 3 to 5. X, because we don't know specifically that's the ratio, but if we have a higher slide, we would just multiply that height times 3, and then the distance would have to be multiplied by 5. It has to be in that ratio. If the slide is about 8 feet long, that's right here, the length of the slide is 8 feet long, what are the height of the slide and the distance from the base of the ladder to the front of the slide? So we need to find these two distances. So let's take a step back. And what was Unit 5, Session 1 all about? It was about right triangles and the Pythagorean theorem. So remember, when we have a right triangle, we can use the Pythagorean theorem. You can only use the Pythagorean theorem when you've got right triangles. And what is the Pythagorean theorem? Because that's what we're going to do to use to solve this problem. So we've got a right triangle. We've got two sides labeled and our third side, our hypotenuse, labeled. So what is the Pythagorean theorem? A squared plus b squared equals c squared. Remember, this c, the side alone, is always going to be the hypotenuse. So that c that's always alone is always going to represent our hypotenuse. And remember, the hypotenuse is always directly opposite to the right angle. So this side here is our hypotenuse. All right, so let's plug in our values. So we've got one of our legs is 3x. We're going to square the entire thing, not just the x. Both the 3 and the x have to be squared. Then the other leg is 5x, and we're going to square that entire thing. And we're going to set it equal to our hypotenuse, which is 8 squared. So let's square these. 3 squared is 9, and then x squared is 2. So x squared is x squared. So remember, we've got to square both these values. Each term, part of the term, has to be squared. So then we'll have 25. 5 squared is 25. And then x squared is x squared equals 64. 8 squared is 64. So now we've got two like terms. We've got an x squared term and an x squared term. So 9 plus 25, x squared is 34. X squared equals 64. Then we're going to work on solving for x. So I'm going to divide out that 34 from both sides. And now we've got x squared equals 64 over 34. And we know we just did this in the warm-up. To undo that square, we're going to take the square root of both sides. So I'm going to come back over here, running out of space. So I'm going to take the square root of both sides. Square root of this side, and then the square root of this side. And when I do that, I get x equals the square root of 64 over 34. So go ahead and grab a calculator. Let's see what that gives us. So the square root of 64 divided by 34, I'm going to round to 2 decimal places, is about 1.37 when we round it. So x equals about 1.37. So then we need to find, we're not done yet. So we found what x is, but we're not done. So we were asked to find the distance. We were asked to find the height and the distance from the front of the slide to the ladder. So we need to find these two distances. So what we're going to do is, since we know no x, is let's plug in x and multiply it by 3, and then plug in x and multiply it by 5 to find this distance. So we're going to do that. So let's find the height of the ladder. So I'm just going to say ladder, or height of, yeah, that's pretty much the same thing. The height of the slide is, we're going to call that the height of the ladder. So the height of the ladder is going to be 3 times x, and we know x is 1.37. And what do we get when we do that? 3 times 1.37 is 4.11. And that's inches. It wanted us to round to the nearest inch. So rounding would just be 4 inches. That's the nearest inch. And then the distance from the front, the ladder to slide, that distance is equal to 5 times x. We know x is 1.37, so we're going to multiply 5 times 1.37. And again, it asks us to round to the nearest inch. So when I get 6.85, and rounding to the nearest inch, I'm going to round up to 7 inches. So make sure you're following directions and you're reading what it asks you to round to. So we got 4 inches and 7 inches respectively for the distance that we were asked to find. So that is coming from Unit 5, Session 1 assignment. That's number 4. So I did that because I did see some mistakes being made there, so I did want to go over that problem. Remember, you can redo any assignments from the current unit, so you can redo this if you found you did something different than what I have up here. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right, so review from Unit 5, Session 2. So Unit 5, Session 2, we looked at how we can have one right triangle, and then if we draw in the altitude, remember the altitude is going from the vertex and intersecting the opposite side at a right angle. That's an altitude. If you draw in the altitude, then you create 2 more right triangles. And with those right triangles come some patterns. And one of the patterns, if we're asked to find the altitude of the right triangle here, if we are asked to find the altitude length, there's actually a pattern that exists, and it has to do with geometric means. So we learned in Unit 5, Session 2, one of the patterns with finding some sides is that if you're trying to find the length of the altitude, which is BD in this case, it's going to be equal to, so we're going to set up a proportion here. So BD over one of our, let's see here, I'm going to change the BD over AD is going to be one of our ratios. So BD over AD, and then we're going to set it equal to the other side, so this one over here of our hypotenuse, DC, DC over the, BD, the altitude that we're trying to find. And remember, when we have this, we end up with a geometric mean formula where BD, the length of BD squared, is going to be equal to, if we multiply it times AD, because really we're doing cross multiplication here, AD times the length of DC. So AD times DC equals BD. So we're trying to find the geometric mean, essentially, right? So let's plug in the information that we have. We're trying to find BD. We know that the length of AD is given. It's 12, and the length of CD is 8. So now we just do the math. 12 times 8 is 96. So BD squared equals 96. We know we need to take the square root, I'm going to continue down here. So BD equals the square root of 96. Can we simplify the square root of 96? Are there any perfect squares in 96? Factors of 96 that have a perfect square. And there is. I know that 16 times 6 gives me 96. So I can take the square root of 16, which is 4, and leave behind that square root of 6 because we can't, there's no factors that have a perfect square. So BD equals 4 square root 6. So again, there's that cool pattern that occurs at the length of the altitude to the hypotenuse of the right triangle. So the length of the altitude to the hypotenuse of the right triangle is the geometric means of the 2 segments of the hypotenuse. So BD squared equals CD times AD. So that's a pattern that's always going to occur. That's always going to occur. So I color-coded that equation so that you could see. The altitude is in yellow, and it's always going to be the geometric mean to the segments of the hypotenuse that altitude intersects. And that's our geometric mean, that pattern. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right. So I'm going to introduce one of these special types of right triangles that you're going to learn about this week. For time's sake, I'm only going to do the 45, 45, 90 pattern, and then you'll learn the rest on your own. So 45, 45, 90 triangles. So we're going to have one angle, it's going to be 45. You're going to have another angle that's 45, and then that third angle has to be a right angle, 90 degrees. Remember, every triangle adds up to a total of 180 degrees. So when you have this happen, you're going to have two angles that have the same measurement. You're going to have two angles that have 45-degree angle measurements. And then that third is going to be your right angle, or that 90-degree angle. Well, guess what? There's a pretty cool pattern that occurs when you have these angle measurements. And that is across from your two 45-degree angles. So directly across from your two 45-degree angles, the side lengths are going to be the same. So if this side length was 10, then this side length would have to be 10. So these two side lengths of the triangles will always be equal. If this says 20, this side has to be 20. Then your hypotenuse, so remember the hypotenuse is that side directly opposite the right angle. That side length is going to be x, so whatever this length is here, it's going to be that length times square root 2. So if let's do an example here. Let's say that this side length is 12. Well, then this side length would have to be 12, and this side length would have to be 12 times square root 2. Pretty cool pattern, right? So let's look down here, and let me put in a side length, and we can use that side length and then find all the other missing side lengths. Pretty neat because of the pattern. So let's say that this side is 5. Can we find all the other side lengths? Sure, because remember, opposite of our 45-degree angles, those sides have to have the same length. So that means this leg here also has to be 5. What would our hypotenuse be? It would be 5 root 2. Well, what if I gave you the length of the hypotenuse as 10 root 2? Can you find now the other sides? Well, they would have to be 10 and 10. So you're going to be working with that type of pattern this week, and you're also going to learn a different type of pattern that occurs for 30, 60, 90 triangles. That's it for today. So for this week, week 2, which is also the week of January 16th, the key phrase assignment. So what you're going to do this week for your key phrase assignment is I want you to tell me something you learned by watching this recording, and it needs to be content related. I want you to tell me something that you learned content related. So about the math you learned about. Be specific and detailed, and remember, this is how you get your 10 points for watching the recording for this week. And you will have to turn in your notes for the recording for this week, so please make sure you took good notes to turn in for your weekly notes this week. So tell me something that you learned. As always, let me know if you have any questions as you're working through this week's assignments, and have a fantastic rest of your week.